In the dim glow of a Copenhagen evening, the air hums with anticipation. A solitary figure stands by the window, gazing into the darkness, deep in thought. The world outside is in turmoil, but within this room, a revolution is taking shape, not of politics or war, but of ideas. It is 1923, and Niels Bohr, a man whose mind seems to dwell in the future, is pondering the mysteries at the very heart of matter itself. In a world still bound by classical ideas, Niels Bohr stands on the edge of the unknown, ready to leap. Bohr's eyes scan the faces before him, colleagues, skeptics, the curious. He knows his ideas will shake the pillars of certainty. Yet he is calm, driven by a relentless curiosity and a conviction that the universe is stranger, more subtle, than anyone has dared imagine. The world will soon learn that the atom, the building block of matter, is not what it seems. This is the story of a mind that refused to accept limits, a thinker whose questions would open doors to a new reality. Niels Bohr, a man ahead of his time, is about to change the course of science, and with it, the destiny of humanity itself. Before we continue this journey through one of history's most remarkable minds, I'd like to invite you to support the channel. If you enjoy thoughtful stories that explore the lives and ideas that shaped our world, please consider liking this video and subscribing. Your support helps these stories reach more curious minds. Niels Bohr was born in Copenhagen in 1885 into a family where the pursuit of knowledge was not just encouraged, it was a way of life. His father, Christian Bohr, was a renowned physiologist, and the Bohr household was alive with discussions of science, philosophy, and art. From an early age, young Niels was captivated by the mysteries of nature, his inquisitive mind always searching for patterns and explanations. Growing up with his brother Harold, who would become a famous mathematician, Niels was immersed in an environment that valued curiosity over certainty. The brothers often constructed makeshift experiments in their backyard, testing the limits of their understanding with homemade apparatuses. For Niels, learning was not confined to the classroom. It was a journey into the heart of the unknown. The city of Copenhagen, with its cobblestone streets and bustling harbors, became his playground. Niels observed the world with a scientist's eye, fascinated by the ripples in a pond, the flight of birds, and the logic behind games and puzzles. These early experiences laid the foundation for a lifetime of questioning, a habit of mind that would one day transform physics. Bohr's formal education began at the University of Copenhagen, where he studied under some of Denmark's most brilliant minds. Yet, it was not the lectures alone that shaped him, but the culture of open debate and inquiry that flourished in academic circles. Here, Bohr learned that science was not merely a collection of facts, but a living, breathing pursuit, one that thrived on challenge and contradiction. In 1911, Bohr traveled to Cambridge, England, eager to work with J. Thomson, the discoverer of the electron. Though their collaboration was brief and somewhat disappointing, the experience introduced Bohr to the wider world of theoretical physics. Soon after, he moved to Manchester to study under Ernest Rutherford, whose model of the atom would become the launchpad for Bohr's own revolutionary ideas. It was in the vibrant, competitive atmosphere of Rutherford's laboratory that Bohr learned to see beyond established theories. Surrounded by young scientists pushing the boundaries of knowledge, Bohr developed a new way of thinking, one that embraced uncertainty and paradox as tools for discovery. The seeds of quantum theory were being sown, though few could yet imagine the harvest to come. The early 20th century was a time of scientific upheaval. Classical physics, once unassailable, was beginning to crack under the weight of new discoveries. Into this atmosphere of uncertainty stepped Niels Bohr, armed with a radical proposal that would forever alter our understanding of the atom. Building on Rutherford's model, Bohr introduced the idea that electrons orbit the nucleus in discrete energy levels, and that they could jump between these orbits by absorbing or emitting specific amounts of energy, quanta. This concept, seemingly at odds with everyday experience, explained the mysterious patterns seen in atomic spectra, something classical physics could not. Bohr's theory, published in 1913, was met with both fascination and skepticism. Yet, its predictive power was undeniable. For the first time, scientists could make sense of the atom's hidden structure. Bohr's boldness had paid off. He had shown that the path to truth sometimes requires a leap into the unknown. With the publication of his atomic model, Bohr became a central figure in the unfolding drama of quantum physics. His ideas did not stop at the structure of the atom. They soon expanded to the very nature of reality itself. Bohr introduced the principle of complementarity, arguing that light and matter could display both wave-like and particle-like properties, depending on how they were observed. This was a profound shift. No longer could scientists cling to a single objective reality. Instead, the act of measurement itself became part of the story, a radical departure from the certainty of classical physics. Bohr's Copenhagen interpretation, developed with colleagues in the 1920s, asserted that quantum phenomena could not be fully understood without considering the observer's role. Bohr's writings and lectures electrified the scientific community, challenging even the greatest minds of his era. His debates with Albert Einstein, who famously resisted the probabilistic nature of quantum mechanics, became legendary. Through it all, Bohr remained steadfast, convinced that truth was found not in simplicity, but in the complexity and subtlety of nature. In the heart of Copenhagen, Bohr established the Institute for Theoretical Physics, a place that would become a beacon for scientists from around the world. Within its walls, young physicists gathered to wrestle with the mysteries of the quantum world, guided by Bohr's gentle yet probing questions. Bohr's approach to science was collaborative and open-ended. He encouraged debate, welcomed dissent, and valued the interplay between experiment and theory. Under his leadership, the Institute became a crucible for innovation, where ideas could be tested, refined, or even discarded in search of deeper understanding. Despite his theoretical bent, Bohr never lost sight of the importance of experiment. He worked closely with colleagues to design experiments that could probe the quantum world's hidden layers. For Bohr, every new result was not an answer, but another invitation to question, to explore, and to wonder. Bohr's revolutionary ideas were not greeted with universal acclaim. Many found the implications of quantum theory unsettling, even absurd. The notion that reality could be shaped by observation, that certainty was replaced by probability, sparked intense debate. Some accused Bohr of abandoning the rigor of science for philosophical speculation. His most famous adversary was Albert Einstein, whose discomfort with quantum uncertainty led to their legendary debates. God does not play dice, Einstein insisted. Bohr, ever patient, replied, "Who are we to tell God what to do?" Their exchanges, marked by wit and mutual respect, highlighted the deep philosophical divide at the heart of modern physics. Beyond the scientific arena, Bohr faced personal and political challenges. The rise of totalitarian regimes in Europe threatened the freedom of scientific inquiry. During World War II, Bohr was forced to flee his homeland, a refugee from the very forces his work had helped unleash. Through it all, he remained committed to the ideals of openness, collaboration, and the unending search for truth. In the years after the war, Bohr returned to Copenhagen, his hair now silvered by age and experience. The world had changed, and so had the role of science. Bohr devoted himself to promoting international cooperation, believing that the knowledge gained through science should serve humanity, not destroy it. He became an advocate for openness in scientific research, arguing for the peaceful use of atomic energy. Bohr's home became a gathering place once more, not only for physicists, but for thinkers from every field. He mentored a new generation, encouraging them to question, to collaborate, and to look beyond the boundaries of their disciplines. As his health declined, Bohr reflected on a life spent in pursuit of understanding. He took comfort in the knowledge that his ideas had sparked a revolution, but he remained humble, aware that each answer only opened new questions. For Bohr, the journey of discovery was its own reward, a never-ending dialogue between mind and nature. Today, the legacy of Niels Bohr echoes in every corner of modern science. His insights laid the groundwork for quantum mechanics, unlocking technologies that shape our lives: computers, lasers, medical imaging, and more. But Bohr's influence extends beyond physics. His spirit of inquiry, his embrace of uncertainty, and his belief in the value of dialogue continue to inspire scientists, philosophers, and dreamers alike. Bohr taught us that the universe is not a machine, but a mystery, one that yields its secrets only to those willing to question, to doubt, and to imagine. His life stands as a testament to the power of curiosity and the courage to think differently. In the end, it was not certainty, but wonder that drove him, a wonder that still calls us to look deeper, to ask why, and to never stop searching. As the light fades and the chalk dust settles, we remember Niels Bohr not only as a scientist, but as a guide, a mind that changed the world, and a voice that reminds us the greatest discoveries are yet to come. Thank you for spending this time exploring one of history's remarkable minds. If you found this journey meaningful, please consider liking the video and subscribing. It helps us continue telling thoughtful stories that inspire curiosity and understanding.